For question number 4A and B, discuss the importance of fault analysis and please include an example. So we know that fault in analysis is a critical aspect of power system analysis as it ensures the safety, reliability and stability of electrical power system. So power system are exposed to various faults such as short circuit, open circuit and equipment failures, which can cause several consequences if not addressed appropriately. So the key reason why fault analysis is very important is because system protection design ensures system stability, minimize equipment damage, improving safety and optimize economic operation. So the first one is for system protection design. Fault analysis provide the information need to design and set up protective device. For example, circuit breaker and relay. For ensure system stability, the PSAs can be disturbed during fault analysis. Fault can help ensure that the system can be returned to a stable state post-fault. For example, during a lighting strip that caused a line fault. The third one is minimize equipment. So fault can cause excessive current of voltage, and a generator winding short circuit can result in overheat, but protective device limit the exposure to such condition. For improving safety, fault can pose safety hazard including electric shock, fire or explosion. It can ensure systems are designed with protective measures to minimize the risks. The last one is optimize economic operate. So fault analysis reduce downtime and costing repair by enabling fast fault identification and resolution. Okay, so for example of the importance of fault analysis in Malaysia can be seen in the major blackout on August 3, 1996, which caused a widespread power outage across peninsular Malaysia in several houses. The disruption was triggered by a lighting strip at a Gurun substation in Kedah. So for the question B, okay, we know that fault at bus 4 ZTH is equal to Z44 equal to J 0.2475, and we need to find IF, V1, V2, V3, V4, I12, I13, I14, I24 and I34. So this is the equation for IF for V4 over Z44 plus Z4. So for the IF, we calculate and the answer is negative J4. So the second step is we need to find the bus voltage, which is V1 until V4. So the formula of V1 until V4 is V1 0 minus negative J 0.135 multiplied by negative J4. So the bus voltage for bus 1 is 0.146 pu. So for V2, the bus voltage is V1 minus negative J 0.0975 multiplied by negative J4, and the answer is 0.91 pu. So until the V4, and then we need to find the short circuit, which is 1I2, 1I3, 1I4, 124 and 134. So the for I12, the formula is V1 minus V2 divided by Z12. So the answer is J 0.3. For I13, the formula is V1 minus V2 divided by Z13, and the answer is negative J 1.5. For I14, the formula is V1 minus V4 divided by Z14, so the answer is negative J 1.5. Same like I24 and I34, use this formula and get the answer. So that's all for me. Thank you.
Assalamualaikum and hi. My name is Nur Syaratul Amir Afiqah binti Sahidin and my matrices number is B012210175. So today I'm going to explain the solution for question 4C for the assignment 1. So firstly, the question asks to find the Thevenin sequence impedances for the fault at bus 1 and calculate the fault current in per unit for the following types of fault. So number 1, a bolted single line to ground fault at bus 1. Number 2, a bolted line to line fault at bus 1. And number 3, a bolted double line to ground fault at bus 1. So before we find these three, we have to draw for the positive sequence, negative sequence and zero sequence for the one line diagram of a 4-bus power system. So firstly, we have to draw for the positive sequence. We have the generator symbols and we have to find where the fault is occur. The fault occur at bus 1. So we have to look from the bus 1 and see which impedances parallel with. So this part is parallel with this part. So I assume this as a ZA and I assume this as a ZB. So ZA J0.05 plus J0.15. So the answer is J0.2. So for the ZB, J0.6 parallel with J0.3 because this is in the parallel circuit. We have to plus it with these two. We will get the answer J0.3. So after we have this answer and this answer, we have to parallel both impedances and find the answer for positive sequence. So we get the answer J0.12 for the positive sequence. So next, we move to negative sequence. The negative sequence do not have the generator symbols, but the arrangement of the circuit has the same like positive sequence. So the answer will be the same as positive sequence. So we have Z2 here, J0.2 parallel with J0.3. Why? Because we already find for the ZA and ZB. So we just have to calculate these two until we get the same answer with the positive sequence. So we get the J0.12 for the negative sequence. For the zero sequence, by referring to this one line diagram, we can design for zero sequence. So first, we know that these two parallel with each other and will make the answer J0.2. So we simplify the circuit by writing these two values into one value. So we will get this answer. Why we have to simplify the circuit? Because it will be easier to find the zero sequence. So we move to the zero sequence. So we see that Y connection meets the delta connection. So it will be open circuit for this part. So next, from the transformer 1 until transformer 2, Y connection will meet Y connection. So it will be closed circuit where the circuit is connected to the ground. So for the generator 2, we will see that this delta connection meets the Y connection. So we know that it will be open circuit again. So how do we find the value of zero sequence? Firstly, we know that the fault is occur at the bus 1. So from here, we see that closed connection only these three. So if this open circuit, we don't or we just ignore the value because it didn't connect it with the ground. So from here, we know that J0.15 is parallel with these two. So we will get the answer J0.09375 for the zero sequence. So after we finally calculate for the zero sequence, positive sequence and negative sequence, we finally can solve for these three questions earlier. So the first question asks, a bolted single line to ground fault at bus 1. A bolted means the ZF value is 0. So first, single line to ground is IA to the power of 0 equal to 3 times EA divided by Z to the power of 1 plus Z squared plus Z to the power of 0. So we will get the answer, negative J 8.99 ampere. Second one, a bolted line to line fault at bus 1. The IA power of 1 equal to EA divided by Z to the power of 1 plus Z squared. For line-to-line fault, we don't need to calculate for zero sequence. So that's why we have to find for IB. So for the IA to the power of 1, we will get the answer negative J 4.167 ampere. So IB, negative J square root times 3 times IA to the power of 1. We will get the answer negative J 7.217 ampere. So the last question is, a bolted double line to ground fault at pass 1. As I said, a bolted means ZF value is 0. So we just put ZF here as a 0. So we will get the answer for IA to the power of 1 is negative J 5.793 ampere. So after we find for the IA to the power of 1, we have to find for the IA to the power of 0. So we will get the answer J 3.252. And then we have to find for the double line to ground fault. So 3 times IA to the power of 0. So we will get the answer J 9.755 ampere. So that's how you answer those 3 questions. If the question is mentioned bolted, we know that the ZF is 0. So we don't have to put the value of ZF. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azib Yasmidan and I will present for the question number 5A. State the types of faults in power system with the help of drawing. Sketch at least 2 examples of each fault respectively. Okay, for the number 1 fault is a symmetrical fault, which is line to line to line fault. Such types of faults are balanced. The system remains symmetrical even after the fault. The triple line fault occurs rarely, but it is the most severe type of fault, which involves the largest current. This large current is used for determining the rating of the circuit breaker. And the next one is the 3-phase line to the ground fault. The 3-phase line to ground fault includes all the 3 phases of the system. The 3-phase line to the ground fault occurs between the 3 phases and the ground of the system. The probability of occurrence of such type of fault is nearly 2 to 3%. Next is the unsymmetrical fault. And the first one is line to line fault. Line to line fault occurs when 2 conductors are short circuited. The major cause of this system of faults is the heavy wind. The heavy wind swinging the line conductors, which may touch together and hence cause short circuit. The percentage of such type of faults is approximately 15 to 20%. And the next one, we have double line to line ground fault. In double line to ground fault, the 2 lines come in contact with each other along with the ground. The probability of such types of fault is nearly 10%. And the next one, I will present about question 5B. Figure question 5B shows the initial no load with the generator operating at their rated voltage, where the rating of the generators and the transformers respectively with the percent reactance marked on the diagram. Given that all the resistance are neglected and the line impedance is 160 ohm. Determine the fault current and the amount of short circuit capacity when the 3-phase fault occurs at A. And the solution is, for the base power, we will use the 100 MVA, and the base voltage on the high voltage side is 200 kilovolts, and base voltage on the low voltage side is 20 kilovolts. And then for the base impedance on the high voltage side, we will use the formula and we will get 400 ohm. And for the base impedance on the low voltage side, by using the 20 kilovolt, we will get the 4 ohm. And the next one, for the line impedance, by using the formula XL over Z base on the high side, we will get 0.4 pu. And for the transformer reactance, that is already in per unit 0.16 pu. Next, for the generator reactance G1, which is 40 megavolt and 20% reactance, by using the formula we will get 0.096 pu. And next, for the generator reactance at 2, by using the 60, we will get 0.144 pu. Next, by combining the generator 1 and generator 2 in parallel, we will get 0.0576 pu. And for the X total, by adding all the value, we will get 0.6176 pu. Then for the I fault current in pu, 1 over X total equal to 1.619 pu. And for the I fault in normal value, which is I fault pu times S base over the power of 3 times V base, we will get 4674 ampere. And for the short circuit capacity, by using the formula given, we will get 162 megavolts ampere. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Akiki Atikowa bin Yaakob, and I will present about question 5C. The reactance data for the simple power system illustrated in figure Q5C are in per unit as referred to a common base. Find the Thevenin sequence impedance for the fault at bus 2 and calculate the fault current in per unit for the following types of fault. Okay, for the first question is a bolted single line to ground fault at bus 2. Second question is a bolted line-to-line fault at bus 2. And the third question is a bolted double line to ground fault at bus 2. Okay. This is the one line diagram of a 4-bus power system. First, we need to find the positive sequence, negative sequence, and zero sequence. For the positive sequence, there has a generator here and generator 1 and generator 2. So for the first one, we need to calculate, we need to divide to the two section because the fault is as bus 2. So before the fault, we need to assume as a section, and after that is a B section. So first we need to find ZA. First of all, we need to calculate the parallel of transmission line 1 and transmission line 2, and plus the transformers 1 and plus with the generator 1. Okay, for the ZA, we put in the formula and we got the impedance of ZA is equals to J0.4. Okay, for the ZB, we calculate the transformers 2 plus by generator 2, and answer is J0.1. Okay, after that we need to find the Z1. Z1 is the parallel from the ZA and ZB. So the answer is J0.08. For the negative sequence is the same as a positive sequence, but there has no generator in the circuit. So the equation is the same. So Z2 is equal to Z1 and Z2 is J0.08. Okay, for the zero sequence, the circuit is there has no connection from this because there has a delta and Y connection to ground, and at the transformer 2 has also Y connection to ground and with a delta. So first we need to find the section of A and B. So at the fault is at bus 2. So before this we assume as ZA, and after this is ZB. We did not to use to calculate the S generator because there has no connection here and here. So for the ZA is transformers 1 plus with the parallel with transmission line 1 and transmission line 2. So this is the formula, and the calculation is, the answer is J0.35. And for the ZB, just only need to add the X transformers 2 So the answer is J0.05. Okay, next we need to find the Z naught equals to ZA parallel with ZB. And the answer is J0.04375. Next, for the first question, is a bolted single line to ground fault at bus 2. So we need to find IA. IA is equals to 3 IA naught equals to 3 EA divided by Z1 plus Z2 plus Z0 and plus ZF. So for the ZF, it is a bolted, so we can assume that ZF is equal to 0. So we just need to put the answer, and the final answer with minus J 14.724 ampere. Okay, for the second question is a bolted line to line fault at bus 2. So first we need to IA1 is equals to EA over Z1 plus Z2 plus ZF. We assume ZF is equal to 0 because it is also as a bolted. So 1 over J0.08 plus 0 J0.08 plus 0 is equals to minus J 6.25 ampere. Next, we need to find IB. IB is equals to minus J sub 3 IA1. Okay, we put the answer here, and the answer is minus 10.83 ampere. Okay, for the third question is a bolted double line to ground fault at bus 2. So we need to find IA1 equals to EA plus or divide by Z1 plus Z2 over the Z2 plus Z0 plus 3ZF. It also has a bolted, so ZF is assumed as a 0. So the answer is minus J 9.235 ampere. After that, we need to find the IA naught. So the formula is EA minus Z1 IA1 or divide by Z0 plus 3ZF. It also assume as ZF equal to 0. So we put in the calculator, and the final answer is J 5.97 ampere. After that, we need to find the IF. Uh, the formula for IF is 3 IA naught. So equals to 3 times J 5.97, and the answer is J 17.91 ampere. Okay, that's all from me. Thank you.